Okay, let's dive right into this. Have you ever looked at a stream or a little river on a piece of property and just thought, man, I really need to get across that? Well, building a wooden bridge over moving water is a classic and honestly absolutely fascinating engineering challenge. But it's also where a lot of DIYers end up accidentally building really expensive temporary dams. Oops, you're not just tossing some scrap wood over a gap here, you literally have to meticulously calculate for moving water, constant moisture, and totally unpredictable weight loads. So, welcome to today's explainer. We're going to look at the blueprint for the easiest, most common design for DIY or small-scale applications, the beam bridge. Together, we're going to architect a timber span from scratch.
To pull this off, we need a really clear plan of attack. So here's our step-by-step agenda. First, planning and material prep. Next, preparing the bank foundations. Then, placing the main stringers. Fourth is installing the decking planks. And finally, constructing those safety railings.
So we're essentially going on a chronological journey today. We're starting at a muddy, completely impassable riverbank and moving all the way to a fully functional, safe, and super durable bridge. It is an incredibly satisfying progression, so let's just get right into the very first step.
All right, phase 1, planning and material prep.
Now, before you even think about picking up a shovel or heading to the lumberyard, you've got to do your homework. Always check your local regulations and contact environmental agencies before disturbing natural waterways. It's absolutely crucial. Once you get the green light, it's time to gather materials. And this brilliantly illustrates a key point. Your material choices literally determine your bridge's lifespan. You absolutely must select heavy-duty, pressure-treated lumber like Douglas fir or incredibly rot-resistant hardwoods. Why? Because moisture is your absolute #1 enemy here. So whether you're building the sills for the bank foundation using heavy 6x6 or 4x6 treated timber, or selecting thick 2x8 or 2x10 logs to actually span the gap, or even just picking the 2x6 cedar for your walking surface, your material prep has to prioritize fighting moisture and rot. Now, there is a single critical number you need to keep in your head during this phase: 100. When you're out there with your tape measure, evaluating the location and measuring the span, you aren't just measuring the distance from dirt to dirt. Nope, you have to measure carefully to ensure your bridge sits safely above the 100-year flood level. Water levels change dynamically, right? The very last thing you want is your beautiful new structure just washing away downriver in a historic weather event. No way.
Which leads us directly to a big engineering question. How do we anchor safely away from that moving water? We've got our plan, we've got our heavy-duty materials prepped, so now we need to get our hands dirty and actually touch the earth. Phase 2, preparing the bank foundations.
Okay, this is where we really have to adopt a safety-first mindset. Remember, your bridge is only as strong as the earth it rests on. Let's walk through the micro actions to construct these abutments. Step 1. Dig out perfectly level trenches on both riverbanks. You absolutely need flat areas. Step 2. Lay your 6x6 or 4x6 treated timber sills parallel to the riverbed. And step 3. Anchor those sills super deep into the ground using heavy rebar, or, for a more permanent base, pour concrete footings. Now listen closely to this crucial detail. You must place your foundational footings far enough back from the moving water to entirely prevent erosion. If that moving water eats away the dirt under your sills, well, your foundation fails and the whole bridge collapses. Simple as that. So right now, our banks are fully fortified and anchored safely away from the current. But look at all that empty space. Now that our foundations are set, how do we actually cross the water without the whole thing just sagging right in the middle? We obviously need a solid structure to carry the load. Which brings us to phase 3, placing the main stringers. This is the really exciting moment where our blueprint actually solves the physical obstacle of the gap itself. Stringers are the thick horizontal logs or treated timber beams that span the gap and rest flat right on top of your bank sills. Depending on the length of your crossing and the specific weight requirements you need, you're going to select thick 2x8 beams, 2x10 beams, or even really heavy logs. You set these beams perfectly parallel to each other, straight across the river, resting them securely on top of those bank cells we just built. So the crucial point here is exactly how we ensure this whole skeleton doesn't shift around. You literally must lock the stringers to your bank cells permanently. You do this using heavy-duty metal hurricane ties or long zinc-coated lag bolts. You definitely cannot just rest the wood on top and hope gravity does the work for you. Moving water, high wind, and just the weight of people crossing will absolutely shift the structure.
And hey, tying back to our material prep focus earlier, zinc-coated hardware is totally essential because it resists rusting in that constant wet environment. All right, the skeleton is completely secure. It's bridging the gap flawlessly. But how do we actually walk on it? I mean, balancing on a 2x10 beam over a rushing stream isn't exactly the safe, relaxing crossing we're looking for, right?
That takes us to phase 4, installing the decking planks.
Welcome to the stage where our raw, heavy-duty skeleton finally transforms into a functional, inviting pathway. But hold on. Before you start laying down wood, you really must evaluate foot traffic versus heavy machinery. The intended use of your bridge strictly dictates the material thickness you have to choose. If your bridge is only ever going to see foot traffic, standard 2x6 boards are completely fine for your planks. But if you plan on driving heavy machinery or vehicles across it, that intended load dictates extreme material thickness for your planks and drastically heavier stringer load requirements down below.
Assuming we're building just for foot traffic, let's break down the action here. First, you place your 2x6 cedar or pressure-treated boards perpendicular over the main stringers. Then, you fasten them down with absolute precision. You need to drive 2 heavy-duty exterior deck screws through both sides of every single board, straight down into the underlying stringers. Using this heavy-duty hardware ensures the boards aren't going to warp or lift up over time. And as you're fastening those boards, pay really close attention to this measurement, 1/4 to 1/2 inch. That is the exact gap size you must leave between every single decking board. If you push the boards entirely flush together, standing rainwater literally is nowhere to go. Plus, wood naturally swells when it gets wet. Leaving that small gap is the absolute secret to allowing proper rainwater drainage and preventing your entire deck from buckling under the pressure of natural wood expansion. And finally, phase 5, constructing safety railings. We actually have a walkable surface. But to make it a true finished bridge, we have to move into the finishing touches. This ensures the bridge is safe for walkers and totally protected from the elements. First up, attach your uprights. You'll bolt vertical 4x4 posts near the outer edges of the main bearers on both sides. Next, you add the horizontal handrails, securing them right along the inner faces of your vertical posts. And lastly, and I really want to strongly emphasize this step, you must apply a protective sealant. Paint all the exposed wood surfaces with a water-resistant exterior wood stain. This is basically your ultimate defense to stop rot and ensure your bridge lasts for years and years. Wow, so we've built an incredible structure today. But now it's time to take a look at your own landscape. What is your estimated span? Are you going to carry just foot traffic, or do you actually need to support heavy machinery? And is your riverbed really deep, or does it dry up seasonally? Let these vital design questions inspire you to evaluate your own property, figure out your load and dimension requirements, and cross over into starting your very own bridge blueprint. Get out there and start planning.